Alright, calculus students, welcome back once again from my palatial home office. You might get to see my cat today. You didn't get to see her last time, but we'll see. So today we're going to talk about areas and elections. Today's notes, this section is way, way, way easier than any other section we've talked about up till now. It's technically not really calculus, although it is because we're talking about areas under curves. So we're going to start this out by taking a look at an example of a voter distribution. So we have some issue here, and I'm going to do my best to draw this distribution in. Let's say we have a distribution that looks like a bell curve. That's a pretty good bell curve. All right. And we've got two different opponents on this one issue. This issue can be whatever you want it to be. So it can be like grape jelly versus strawberry jelly. And we have we have position A, and then we have position B. And then we have individual beliefs that aren't necessarily exactly where position A and position B are. So let's say we've got somebody who's right here. We'll call this person little a. Somebody who's right here. We'll call this person little b. And somebody who's right here. We'll call this person little c. In general, and this is how human beings act, if this is like the continuum of all possible positions on an issue, again, over here grape jelly, over here strawberry jelly, and then right in the middle would be people who are, they're pretty jelly impartial. Then person A, who's mostly grape jelly, but kind of sees the value of strawberry jelly, is going to vote for whichever candidate has a position that's closest to them, which means that little a is going to vote for candidate A. The same is true for all the other people. Little b here is a little bit further away from candidate A's position, but in general, they're going to vote with the candidate that's closest to them, which in this case is B. And then that means that candidate C is going to vote for, or not candidate C, person C is going to vote for candidate B, because that's who they're closest to, because B is closer to grape jelly. Now, this question is different than if we asked a general question. I want to undo that. So let's ask a general question about who we would expect to win this election. So for that question, we want to find a middle point between A and B, because that middle point is going to decide whether voters are going to go for A or for B, and then whichever side has more stuff under it, that's the side that's going to win. So I'm going to say directly in between the two is probably about right here. Okay, I'm trying to draw, I promise. Okay, is about right there. And if I draw a line splitting the distribution between the two, that is not a very good line. So we'll go up, and then we'll go down. And I ask you who's going to win, A or B, even though in this example, both person A, little a, and person little b would both vote for candidate A, you can see there's a bit more stuff underneath the distribution for candidate B, strawberry jelly, which means strawberry jelly is going to win, which is gross and just morally bankrupt. But so that's kind of how this works, is if you are asked who's going to win, you're looking for the middle point between two candidates, and whichever has the most area underneath their side of the distribution, that's the person who's going to win that election in general. Now, I know a lot of you guys are going to think about the 2016 election with this, because that election is something that people are going to write books about for forever. But let's look at an example here that is 100% not tied at all to any kind of national election. And just because something is true in general doesn't mean it's always true, first of all. So let's say that we have, this is all the voters in America, and we have a couple candidates here, and the issue that they're taking a stance on is, I don't know, it's not strawberry jelly this time, it'll be like, I don't know, spring or fall, which season is best, and like over here is spring, which is why the distribution is kind of leaning towards spring, because spring is obviously better than fall. And over here on the right we got fall. And we got one candidate who is like, they're super, super, super into spring. We're going to call this candidate S. And we have another candidate who is pretty close to exactly in the middle. They like both spring and fall. And I asked you which one of these two is going to win. In general, candidates that have more extreme opinions are going to have a harder time finding a larger portion of the demographic that fits near their position. So if we had a midpoint between these two, spring and fall, we'll put it right there. Because this person is pretty darn close to the middle of the road, that means that they're going to get way more of the distribution. So this is something that is generally true for political elections as well. The closer a candidate's politics are to the middle, the more they can be seen as a moderate. Generally, the more votes they're going to get. In general elections, extremists are almost never elected. And the exception being, of course, 2016. There's a few other exceptions that you can see. In 2000, Bush v. Gore. Gore was way more moderate than Bush was, but he ended up losing by 500 votes. In 1998, in the Minnesota primary, Jesse Ventura, or not in the primary, but in the actual general election, Jesse Ventura won, even though he had some ridiculously extreme views because the party was really splintered. But that's all that gets way more complicated. The general idea you want to know is to find out which one of these two are going to win, you find the midpoint between them, and then whichever one would be on the side with the most stuff under it is the side that's going to win. So that's it. That's really all you need to know for today's part of the assignment. If we take a look at the assignment here, we've got questions 31 through 39. For 31, we've got candidates A, B, and C, and it's asking who little a, little b, and little c are going to vote for. For 33, it says shade the region. Just sketch it on your graph or on your assignment, and you want to shade where the votes for candidate A are going to be and where the votes for candidate B are going to be, and which candidate do you think is going to win. Figure 39 is this one here. For figure 35, or for 35, figure 41, if candidate B withdraws before the election, which candidate will win? So first, which candidate wins? So we've got C is going to get anything from between B and C over. B is going to get anything from between B and C to anything between B and A gets anything from here over to there. So which one would win? And if B withdraws, then who wins? And if B stays in the election but C withdraws, who wins? It can be okay for you to say that it would be a very close race or too close to call for one of these three. Hint, hint. 37. If the election was only between A and B, who would win? If the election was between A and C, who would win? And then if the election was among A, B, and C, who would win? And then 39, sketch what a voter distribution might look like for a two-issue election. Spoilers, there's kind of this would be kind of like two issues. Just spoilers. So that should take you through the rest of the assignment for the week, which was 21 through 39 odd. So let me know if you have any questions. You can hand in your assignment to my box, which is in front of like the office at the school. You can take a picture of it and email it to me. You can take a picture of it and post it on Classroom. Any of those are fine. So I hope everybody's staying safe and flatten the curve.